Okay, now we're going to be looking at lenses. Got my plate here. The fact is, it's going to be a little bit more difficult to use a plate, okay? So we're going to probably draw these a little bit by freehand. First thing we're going to do is draw our principal axis. I'm sure I said this in the other one, but these are called ray diagrams, making predictions based off the drawings of where images will form, not the math. Okay, so we're going to make a line going straight across, and you can make a big line perpendicular to it going straight up and down. Now, if I were going to do this, I think that's close to perpendicular, I would just write by convex. Okay, lens. You'll notice I probably put E's on the end of lens a lot. So go ahead and draw those. I don't know if you could hear the voice talking. All right, so for some of us, it might help if we actually just go like this and draw like the picture of the lens, so we could kind of picture it. We could try to do it with our plate and maybe only make like a little bit of a half a circle here, or like a eighth of a circle, I guess, over here. It's easier just to do it this way. Make sure you have the line down the middle, because that's where we're going to act like our light bends. Remember, I said in the first video that this is talking about thin lenses, not thick ones. Okay, so now we have to pick focal lengths. Now, for each side of this, there's going to be a focal point. Okay, if light were shining on this side, it would concentrate over here to a focal point. If it's shining from this side, it would concentrate. It all combine over here into one point. That'd be the point at which you would put on like a leaf or something if you're going to try to catch it on fire or something like that. So in my case, I'm going to pick 5 centimeters on each side. If this is a perfectly biconvex, each side would have the same curvature. So I'm going to put my 5 in the middle, mark 10, mark 0. So those are my two F's. They're both at 5 centimeters. You don't have to do that, but I just know that it works out on the page. Okay, call this F. I'll call this F. Now you may ask, where is C at? C is not present in this. We do not need it. Okay. C, remember, was the center of curvature. So first off, I'm actually going to put my my object right at about 2 times the focal point. Okay. I shouldn't have made a dot there. That's okay though. And I'm going to make it 3 centimeters high. Doesn't matter. Okay. There's my object, 3 centimeters high. Shadow today's pretty bad. It's during the day. I don't have my extra light. Okay, so let's draw our 3 principal rays for lenses. Okay. One's going to be involved with one focal point, and the other one's going to be with the other focal point, and then we have a third that's going to go right through the middle and go undisturbed. So our first one's going to go parallel to the principal axis. We could draw it right to the middle. That's why if I was doing this on my own, I would just maybe write the name, and I wouldn't even put any kind of curves, because I know I'm going right to the center of the lens. We're going to act like that's where the refraction takes place. And it's going to go right through the focal point. Okay, I'm going to label that number 1. All right, so hopefully I could actually draw these pretty straight. I drew them ahead of time, and they came out pretty good. Right. So that's the first one. All right. I'll tell you what, let's do number 2 going right through the middle. I like that one. All right. Make sure these lines over here are really long, as long as you can get all the way to the end of the page, because you might go off the paper. Number 2 just goes all the way straight through the middle. Oh, see, I almost made that too short. Number 2 goes this way. Straight through the middle, no refraction takes place. Whatever refraction were to happen, remember we'd have like this little offset here. If you remember that number 5 we had in the problem sheet, but the offset would be so small that we don't really need to focus much on that if it's a really thin lens. Then the last one actually goes through this focal point. So the way I like to imagine this, imagine if the light was coming this way. It would hit the middle. Anything parallel to the principal axis would hit the middle of your lens and go right towards the focal point. Okay? And so this one goes through the focal point and then comes up parallel to the principal axis. Okay? And there goes a mirror. All right, that's number 3. Okay, so you can see that they converge over here. And I'm hoping it comes out about right. Yeah, it's pretty close. All right. And it's actually inverted upside down. See, we're locating where the head is at of the arrow, not the tail. The head is over here. All right. So this is the image. If you were to actually measure these, you would find that they're pretty close to being the same. So our image over here is real. Remember I made a comment about if it's upside down, it's going to be real? Well, it's upside down, so it's real. Also, if I were to take a screen like another piece of paper and I had this lens for real, I'd be able to go like this, and I'd actually be able to see it on the screen, the piece of paper, it would show up there. All right, so it's real. It's inverted. And in this case, the magnification is equal to 1. That's when our object is at 2f, 2 times the focal length. Okay. All right. So those are the 3 rays you draw for biconvex. Now, how about what happens if we were to take our object and we were to move it back, or we were to move it closer? Okay, somewhere between f and all the way back. Let's try to just picture this. Okay, I'm just going to focus on ray 2. So if we get closer, okay, I don't know if you could kind of get a sense of that. So this is where our object is going to be, and I move it closer. This image is going to come in closer. Now the question is it going to get bigger or smaller? Okay, think about this too. This ray 1 here that goes straight, it's going to be still going through f, right? No matter how close we get, it's still going to go through f. Okay? How about if I move it back? What's that going to do to the image? Okay. You can draw those to find out. Right? Does it make them bigger? Does it make them smaller? The only weird one we would have here really is if we took O and we moved it inside of F, but that would be for either a later video or we just might look that up in some notes. Okay. Next is the biconcave. Okay. We're going to do the same thing. It's amazing. I'll make examples, then I won't put them right next to me. I'm sure some of you are not surprised by that. Oh, look at that. Oh. It's pretty much terrible. But there's my biconcave. All right. I do have it right here. Once again, I'm going to make my focal points at 5 centimeters. I just know it's going to fit on the paper if we do that. Okay. I'm going to put my object out here. I'm actually going to make it a little bit bigger. It won't hurt in this one to make it a little bit bigger. It's hard to, like, when we start like this because I'll make these suggestions and won't know why until the very end. Okay. So remember that this biconcave, you saw my example for myself. It's biconvex. It's a converging. They converge. from our first video with the notes. This one, they diverge. It's a diverging mirror, so when they come in, they spread out. Image will not form over here. It must form over here somewhere. So I'm going to wait for the hardest one to the end, the one that I tend to forget about. Okay. So it goes straight, and it's going to go away from this focal point. Instead of converging at the one over here, it's going to go away from this one. Now I know what happens, so I'm going to make this dotted line here. Okay, this dotted line is an extension of this light ray out here. Okay. Next, I'm going to have it go right through the center. Okay. Which one did I do that with? Last one. Right through the center. Okay, that's number 2. Unaffected. Okay. So I think maybe you could already see this, right? This would go through here. If we dotted the line back, it'd be right along the same line, same light ray. So that you can imagine like dotted line back to here, this dotted line back to here. Our image should form right here. It should be smaller. Okay. If you ever had a lens like this, I don't know about your glasses if you do it. Anyway. But if you ever had a nice biconcave lens, you would see whatever in the lens, and it would be small and upright. So how about this third one? So this is the weird one. It points at this F. Okay? It points right at this F. But don't go all the way to it. Okay? Stop at the lens, and then it shoots out straight. Now the one thing we should know, I already said it how many times, it's a diverging lens. Okay? It's a diverging lens. So if any of these light rays come together over here, like if you were to go like this and go down and these come together, you go, oh, something's wrong. Okay? Now, some people get mixed up because they look at this one. We always look at the refracted light ray. So that's why we draw the dotted line back from here, we draw the dotted line back from there, and we would draw the dotted line back from our refracted one, this one. Okay, you can see that they all come together right here. I'm not going to use a ruler. So that's our, that's our image. Okay. So in the last one, I talked about putting a piece of paper like over here and being able to see it on the piece of paper. This one you wouldn't be able to. Since you can't get it on the screen, it's called virtual. Also, I talked about if it's upright, it's also going to be virtual. It's virtual, it is upright, and how about the magnification, how big it is? It's less than, oh, I was going to put less than I. Less than 1, that's a 1. That's a 1. Less than 1. Okay? And regardless as if we move it out here, whatnot, outside the focal point, we're always going to get the same setup and the image is going to be smaller. All right. Let me check my time here. Don't even know how to do that. Oh, I can't see it right now. So, tell you what, we're going to do one more. I'm going to do one more. It's going to be with the biconvex lens, but I'm going to move it inside the focal length. I did not draw this one ahead of time, so we're winging it. Like I said before, all my stuff is at school too. I could just look it up real quick, do the math, but I don't necessarily want to right now. So I tell you what, I'm going to draw it over here. Okay. Okay. So this is going to be my biconvex. And I'm still going to put the focal points at 5 centimeters. You see that one's almost off the page? Now here's a weird one. We're going to put this one inside of here. I'm going to make it small. It's the object. Okay. Make sure you can actually see it in there. So what happens if we move the object less than focal point, less than the length of the focus? Okay. Here, we'll write like this. So it doesn't look like 0. Uh-oh. Everybody knows what that means. So, first one. Draw. I hope I get this on the paper. Draw here. And then through the focal point. Okay? Alright, I'm trying to make sure I have room. I'm going to put the one on this side. Okay? Number 2, second one, goes right through the middle. I think we'll catch on here really fast that they don't converge. Okay? Like you could tell right here that this line and this line, this light ray and this light ray, will not converge. Okay? And the last one, here's where I get tricked up to myself. So if the light ray are coming this way, right? It goes through the focal point. So actually this would go away from the focal point and it would come out parallel like this. Okay, you can see that those 3 light rays do not converge. So where do they converge? We're going to draw dotted lines back from our refracted rays, not from our rays over on this side. So I'm going to draw this back here. Okay, my green. I'm going to go backwards. Why not? Orange. Messy. It's okay. And my running out purplish grayish color. So some people might do this and go, well, wait a second. No. This one should go back right to it. I'm going to fudge it a little bit. There we go. I kind of tilt my ruler just to make it line up pretty good there. But let me tell you what, if you noticed that it was pretty close anyway. And so here. Okay, that's our image. So our image, could we actually put the light comes this way, or at least it should, right? If I put a piece of paper over here, will the image form on the paper? No. So that means it's virtual. It also follows the rule that it's upright. The magnification, we'll do upright. And the magnification is greater than 1. Okay. So there it is. Okay. I'm trying to look and see if I made a mistake for some reason. No, I was okay. For some reason I thought in the other one I put greater than. Okay. But in this one it's greater than 1, which means it's just bigger than the original. If we think of 1 being the original, this one would be greater. Okay? And so when you do your mirrors, if we were to go back and look at the mirrors, and it's probably going to be some sort of assignment or at least like check for you, it would be to go back and even in the mirrors move your object in and outside of the focal points and see what happens to the image formed. Like this one, we would go from combining over here on the right and it being a upright, or I'm sorry, inverted real image to a upright virtual image and bigger. Okay. This one you wouldn't be able to burn any dandelions or anything like that, or get anything really hot if our object that was giving off the heat, like the sun, was that close to a lens, which it can't be anyway. All right, that's it for this one.